So let's begin at the beginning. We know that carbon dioxide traps heat in the atmosphere. This was 19th century science. It's been established for a long time. We know that the buildup of carbon dioxide has been accelerating, and with it has been an acceleration in the rate of warming. The orange line is our temperature, global temperature history over the last century and a few decades. We currently have warmed the equivalent of a little over 2 degrees Fahrenheit, and we're on track to warm 2.7 Fahrenheit or 1.5 C in the next decade, and to break the Paris Climate Treaty before mid-century. By 2045, we're on track to reach 2 degrees C. And the Paris Climate Agreement was designed to stop warming at 2 degrees C and aspirationally stop at 1.5 degrees. So we're not going to make these. We know that the warming is pronounced. It's highly variable. It's a scientific problem to figure out the role of El Nino, the role of the Atlantic Oscillation. So there are still a lot of questions in climate science, but what is indisputable is the fact that the world has been warming dramatically. This is the coldest time in the North Atlantic since Ben Franklin took measurements going back and forth between Boston and England. And the reason for that is because it's fresh water that has melted off of Greenland. That fresh water has shut down a series of currents called the global conveyor belt that carry heat from the surface ocean down to the deep ocean. By slowing that down 15 to 18%, we are exporting less heat to the deep ocean, meaning that there's more heat on the surface and more heat in the atmosphere. And this is one reason why the rate of warming is accelerating. With the buildup of heat in the tropics of the Atlantic and in the southern Atlantic, we're seeing superstorms. We're considering a whole new category of hurricane, a category 6. And we're seeing excess warming down here, which is causing melting in the Antarctic area. And you can see all the meltwater coming off of Antarctica. Everybody's favorite question is, why aren't we looking at a natural cycle? Is this part of a natural cycle? So let's put that to bed right away. We know what natural cycles in climate are. We have an amazing geologic archive of fossil air bubbles that are trapped in ice. And these bubbles can be studied and analyzed. Ice cores taken by multiple nations in Greenland and Antarctica have looked at this issue. We melt the ice in a vacuum chamber, and we simply measure what's the carbon dioxide content, the methane content, the oxygen content, and we get perfect little descriptors of the atmosphere as it was going back almost 1 million years, 800,000 years. And the history of atmospheric chemistry looks like this. This is the carbon dioxide content. This may look like just a complex line with no pattern, but in fact, these low periods of carbon dioxide are ice ages. And these high periods of carbon dioxide are interglacials, or warm periods, just like the one we're currently living in. This is our carbon dioxide scale over here. We measure it in parts per million. And over the last 800,000 years, the natural amount of carbon dioxide never passed 280 parts per million. Today, it has reached 415 parts per million. Important to this is the fact that ice ages and warm periods operate on a predictable cycle. We have a 100,000 year rhythm to changing climate, and that is the product of variations in Earth's axis of spin, where we tilt a little bit more towards the sun and a little bit less. Earth goes from more of a circular orbit around the sun to one that is a little more eccentric. And our axis of orbit actually describes a circle in the sky. These are known as orbital parameters. They occur on tens of thousands to hundreds of thousands of years. And as they line up, to make short, cold summers in the Arctic or long, warm summers in the Arctic. You can get the buildup of ice, which reflects more and more sunlight out, driving us into a cold ice age, or the retreat of ice, which allows more and more sunlight to be absorbed and then to emerge as heat, which is then trapped by carbon dioxide and other greenhouse gases. So the last ice age ended about 20,000 years ago, and we now live in what's known as the Holocene interglacial. And these orbital parameters were organized so that their maximum heating potential occurred 9,000 to 8,000 years ago. And since then, they have been driving us down into the next ice age. So we have actually cooled 1 degree C over the last period where we see humans developing agriculture, deforesting areas around cities, and moving from hunter-gatherers into villages and cities. Now our temperature has warmed an additional 1 degree, and we're on pace to warm 4 degrees before the end of this century. And we are seeing a number of tipping points that we have already crossed. The West Antarctic ice sheet is in irreversible retreat. The Arctic sea ice will disappear in the summertime within a few decades. I'll show you about coral reefs, which will experience annual bleaching by mid-century, and the world's mountain glaciers are being lost all over the planet. By the time we reach 2 degrees C, we're looking at drought hitting the Amazon forest, putting it in danger. The Arctic forests of the world are already no longer sinks of CO2, but they are sources of CO2 because of wildfires and drought. And we have a number of other major systems, ecosystems on the planet that are changing dramatically because of this warming. So what are the impacts here in Hawaii? We know from over 100 years of temperature stations across the state that we have warmed approximately 1 degree Fahrenheit. We know that the daily wind speeds are declining more and more. We're seeing light winds and variable winds in our weather forecasts. We know that the waters around Hawaii are getting hotter, and with the decline in the winds and the increase in sea surface temperatures, we are setting record heat just in the last month or so. And we've had 32 record hot days between May 16th and June 9th of this summer. From Honolulu to Lehue, Hilo, all across the state. And these are the product of declining trade winds and hot sea surface temperatures. We are in a light El Nino right now, which amplifies the sea surface temperatures even further. We also have measurements of precipitation in the state going back over a century. All these red arrows pointing down indicates that we are declining in our precipitation. The overall trend is a 6% decrease in precipitation per decade over the last 3 decades. Rainfall is declining both in the wintertime and in the summertime. We see all sides of all islands experiencing drought, which are what the hotter colors are. The strongest drought has hit the Kona region, and we see huge landscapes like this, which have gone into total failure of the vegetation. In between rainfall, streams flow because the groundwater system feeds them. That's called base flow. It's groundwater that comes up through the channel. Measurements of base flow from the U.S. Geological Survey are down in all our stream systems that have gauges, and we're looking at a full century of data here. This is 1920, so this is the 20th century and up to present day. In fact, you may be aware that the Waianae Coast no longer has a flowing stream except when it has rained within that watershed. One consequence of this drought and invasive grasses is an increase in wildfires. So the annual area burned in Hawaii is increasing. One reason is because drought kills invasive grasses, and those are immediate fuel for human caused fires. Almost 100% of our wildfires are the result of humans, but it is the background of invasive species and climate change and drought that is leading to the increase in wildfires. These conditions make our ecosystems ripe for invasive species. Our natural species are finely tuned to temperature regimes and rain regimes and elevation, and so they are vulnerable when we change all these conditions, and invasive species are very robust due to these changing conditions, so that now less than half of the landscape in Hawaii is dominated by native plants. And as the area of heat moves up our watersheds, it brings with it mosquitoes and avian malaria into parts of the rainforest that had not seen it before. Globally, extreme rainfall has increased 12%. We now have what are known as rain bombs. These are intense concentrations of rain that are so dramatic that they can actually cause structural damage where they hit. And we've seen these here in Hawaii. April 2018, one system hit Oahu and Kauai, a state of emergency and a cost of $124 million. Over here on the southeast shore of Oahu, we saw the heavily developed watersheds, the fact that they are paved in impervious concrete, that they are steep, that there is a short distance to the ocean. All of this comes together to create a situation that promotes flooding. And during this event, the Wailupe Gulch rose 8 feet, water rose 8 feet. It jumped out of the channel and it flooded across the whole watershed and down onto Kalanioniole Highway. The system also hit the north shore of Kauai. It's been in the news lately. And it's set a national record for rainfall in a 24-hour period, 49.69 inches. The Hanalei River rose 15 feet. It jumped its banks and carved through a small subdivision as it found a new route to the ocean where the pier is at Blackpot Beach. Hurricanes are also changing. As sea surface temperatures rise, there's more fuel for hurricanes. We know that they are larger, they are moving slower, which causes more damage where they're located, but the wind speeds are higher, they are wetter, and the zone of maximum winds around the world, located in the tropical area, that zone has been observed to migrate to the north. Here in Hawaii, just as an example, if we look at the 1994 hurricane season, historically, most of our hurricanes that make it out to the north central Pacific tend to pass south of the Big Island. But last year, we saw a shift and we were in the crosshairs of a number of these tropical cyclones. Modeling and observations support the conclusion that there will be an increase in tropical cyclones near Hawaii. And this is the journal Nature Climate Change, a premier scientific journal. What does it look like when a hurricane hits? Hurricane Michael at Mexico City Beach gives us an example. Total devastation. The annual city budget for Mexico City Beach was $6 million. The cost of just cleaning up the debris alone was $60 million. And so, of course, the state and the feds have to come in with those sorts of resources. Two types of houses. One, where the building code has not been updated, and you simply have a pile of debris, or updated building codes where the houses are built with post and pier so that there is an allowance for storm surge to pass underneath, but even these often lose their roofs, the first floor and even the second floor get blown out, but the structure itself stays intact. Consequently, global weather disasters have doubled in the past 2 decades, and we see storms and floods and mudslides and extreme temperature and droughts and fires all increasing. These are insured losses maintained by the large reinsurance firms, And we know that as insured losses rise, our premiums rise, and the cost of living for all of us increases. Our ecosystems are taking a major hit. The oceans are hotter. Their pH is lower because they're absorbing carbon dioxide. And since 1950, there's 2% less oxygen in our oceans. This leads to bleaching, and now scientists are projecting that reefs globally will decline 10 to 30% of their natural cover once we reach 1.5 degrees C, and to less than 1% of their natural cover when we hit 2 degrees C. By 2050, 98% of coral reefs in the world will be experiencing annual bleaching. Here again, we set up a situation for invasive species. But beyond that, our reefs are actually collapsing. They're being pounded into fields of gravel with waves. They no longer can secrete the carbonate, the calcium carbonate, which allows corals to build reefs, and instead they are being collapsed by seasonal waves. This actually lowers the seafloor, equivalent to a rise in sea level that we wouldn't expect to see till the end of the century. And we're seeing increased wave energy hitting the shorelines, which drives an increase in coastal erosion. Antarctica, the entire ice on Antarctica is in a state of accelerating decline. Greenland, the same. The mountain glaciers of the world, accelerating decline. And the storage of heat in the oceans, accelerating increase, which makes them thermally expand. All of these together lead to approximately 1 meter of sea level rise by the end of the century. That's an extrapolation of the current rates of change, 1 meter by the end of the century. This is at 1.2 degrees C. We're headed to 2 and 3 degrees C. So 1 meter is our minimum estimate. And because the science on the ice sheets and thermal expansion of the ocean is still evolving, we had a paper that came out recently where experts were asked to answer a number of questions. The statistics of their answers concluded that there was a 10% chance of sea level exceeding 6.5 feet by the end of the century. Coastal decisions require long lead times. It would be nice if we could wait for the science to clear up, but we can't. What does 10% mean? If you knew there was a 10% chance that a plane would crash, would you get on it? Most of us would say no. So that's a serious probability. Here is the Western Waikiki, Kaka'ako. In purple, we have flooding by the groundwater system. In green, we have storm drain backflow, where salt water comes out of our storm drain system. And in blue, we have marine water that overflows. And so this is our current high tide situation. We already have some locations of flooding, minor flooding. At 1 foot of sea level rise, we see the Diamond Head parking lot of Ala Moana trigger. And these little pink dots are individual drain holes or manhole covers where salt water is coming back out. And where you see this purple, that's a new wetland. That's where the water table has reached the land surface, creating a wetland. That's 1 foot of sea level rise, 2 feet of sea level rise, and now we reach a tipping point. Between 2 and 3 feet of sea level rise, there's a dramatic increase in flooding. There's 3, 4, and 5 feet of sea level rise. Every red line is a road that's flooded at least 6 inches. That's an engineering standard by which cars begin to fail, and you start to get stalled cars in the water. Now let's rain on top of that. All of that was just salt water. This is what the 2015 El Nino looked like during a high tide, which occurs late in the day when everybody is trying to drive home and getting on the H1 during rush hour. That's when the high tides occur in Hawaii in the summertime. DOT is aware of this. They've measured 140 miles of vulnerable road, 120 bridges. 10 to 15% of all roads in Hawaii are exposed to flooding by sea level at a cost of $1.5 million per lane mile and $14 million per bridge. Re-engineering this system is very problematic. There's a total exposure of $15 billion. We know about coastal erosion and beach loss. We all enjoy surfing. This is the summer swell. And at 2 feet of sea level rise, we see dozens of homes being flooded by just a swell event that we would all grab our boards and go out and enjoy. But again, our tipping point between 2 and 3 feet of sea level rise, every summer we see waves flooding the entire Eva Beach community. Our global carbon dioxide emissions decreasing. Last year, they rose 2.7%. And where we need to cut our global emissions 50% per decade so that we are totally decarbonized by mid-century, and then we actually have to pull CO2 out of the air. These are called negative emissions. In fact, projections by all the global economists are lining up to show an increase in CO2 emissions because of demand for new sources of energy and our inability to deploy renewable energy to meet that demand. Demand outstrips our ability to deploy renewable energy. Hawaii, however, is in a strong position to lead the world. HECO has 7 new projects, phase 1, that have been approved by the PUC. One of these will be the single largest solar and storage deployment in US history. Phase 2 will replace our 180 megawatt coal plant and build a standalone 200 megawatt battery that will feed peak demand at less than the current consumer pricing. Across the state, we have farmers, cattle ranchers, fish farms going into carbon negative. They're not just doing business as usual, they are becoming aware of the need to adapt to the heat and the drought, and also engage in new types of food production that absorb carbon into the soil and into the fish farming activity. Seawater air conditioning is a cutting edge advancement. So these are just a few of the reasons why I'm very optimistic about Hawaii and its role as a leader in the world. We have a responsibility. We need to start educating the people of Hawaii. They need to be informed when they go to make important decisions so that the leaders that they elect also are on board to keep us as global leaders. By leading the rest of the world through this problem, we save ourselves and we can compel the rest of the world to save themselves. So thank you very much.